1-8, other types of inequalities. We've talked about polynomial inequalities. Now we're going to rational inequalities. Rational means what? Ratio means what? Fractions. So we're going to have a polynomial divided by a polynomial. Okay. And this is, in my opinion, this is kind of review what we've been doing. So rational inequalities, the concept of key numbers and test intervals can be extended to rational inequalities. So remember, key numbers, those were the ones that gave us zeros, right? But when we're talking about rational inequalities, now we're looking for the zeros and undefined. What makes a rational equation undefined? Dividing by 0. Okay, so here's what we're doing. I want to know what makes the top 0. I want to know what makes the bottom 0. Those are my key numbers. Okay. Use the fact that the value of a rational expression can change sign only at its zeros. That's when the x value is 0 in the numerator. And undefined values, that's when the denominator is 0. These two types of numbers make up the key numbers of a rational inequality. So what's going to happen is we've got this infinite number line. We're going to find these key numbers to break up this number line into pieces. Each piece is a range. Each range has to be tested into the original inequality to see if we get a true statement or not. If we get a true statement, then that portion of the range is included in the solution. Okay? That all makes sense? Hopefully? Okay. All right, let's move on. Here's a problem. 2x minus 7 divided by x minus 5 is less than or equal to 3. We're going to solve this and graph the solution set. The first thing we have to do is find our key numbers. Before we find our key numbers, we must write this in general form. What does that mean? Equal to 0 or right? So when I go about solving this, I'm going to set it equal to 0 because all I'm doing right now is I'm looking for what makes the numerator 0, what makes the denominator 0. But before I do that, I've got to set it to 0. So that 3 needs to come over. So I'm going to solve the related equation. I'm not going to solve this equation. This inequality. I'm going to solve the related equation. Subtracting 3 from both sides gives me 2x minus 7 over x minus 5 minus 3 is equal to 0. Is that general form? Yes, I've got it set to 0. How do I solve it? How do I combine 2x minus 7 over x minus 5 and a negative 3? Both sides? That means you're going to multiply this one by x minus 5 also? Never thought about doing it that way. Would it work? That's what that's going to do, though, is that's going to get rid of the denominator altogether. And we need the denominator to see where it's undefined. And if we multiplied everything by x minus 5, that would be no denominator. I don't know if that would work or not. I'm going to try it later on, though. Okay. Can you? No, you can't combine those. She's wanting to combine the 3 with the 2x minus 7. You can't do that.
No. I didn't know. Like negative 2 or negative actually be plus 3.5 and then.
Can't do that. Okay. Yeah. If I wanted to combine these two things, is 3 a fraction?
Well, I mean, you can put another one.
Yeah. So how do you combine fractions? You must have common denominator. What would the common denominator be? X minus 5. Well, this first fraction already has an x minus 5, so I'm going to leave it alone. And how do I give the 3 a denominator of x minus 5? Okay. So minus 3 times x minus 5 over x minus 5. Because that's just 1, right? A recommendation here is anytime you're subtracting, change it to addition. So I'm going to change this to addition. And doing that means I need to change that 3 to a -3. Because that -3 has to be distributed. Okay. All right. I now have 2x minus 7 over x minus 5 plus, what's my numerator? -3x plus 15 over x minus 5. Now that I have a common denominator, can I combine them? Okay. So combining my numerators, I have a 2x and a -3x. Okay. I have a -7 and a 15 over x minus 5. And that's as far as I can simplify it. Okay. My key numbers come from x values that make the numerator 0 and x values that make the denominator 0. So what are my key numbers? 8 and 5. Because -x plus 8 equals 0, add x to both sides, 8 equals x, right? X minus 5 equals 0, add 5 to both sides, x equals 5. So those are my key numbers, which means I've created 3 intervals. Does that make sense that I've created 3 intervals? I've got an infinite number line. I've got a break at 5 and I've got a break at 8. Now do you see 3 intervals?
Oh, yeah.
I've got an interval from -infinity to 5. I've got another interval from 5 to 8. And I have another interval from 8 to infinity. Okay. Notice that my intervals have parentheses around them. They will always have parentheses in this case, because right now, all I'm doing is breaking up my infinite number line into 3 pieces. I need to check each piece. How do I check each piece? Choose a value from each region, plug it into the original. Okay. So I need a number between -infinity and 5. How about 0? Okay. Which means I would have, so if I chose, if x equals 0, if I plug that into the original, I would have -7 divided by -5 is less than or equal to 3. Is 7/5 less than or equal to 3? This is true. So part of my region that satisfies this inequality is everything from -infinity to 5. How about a number between 5 and 8? 0 didn't used to be between 5 and 8. Okay, 7, I don't care. So plug a 7 in there. That gives me 7 over 2. 7 over 2 is less than or equal to 3. 7 over 2 is 3.5. 3.5 is not less than or equal to 3, so that's false. I need a number between 8 and infinity. Okay, plugging in 10. We have 20 minus 7 over 5 is less than or equal to 3. True. So the regions that satisfy this are -infinity to 5 and 8 to infinity. Okay, y'all good with that?
Does that mean that any number within those regions would be true?
Yes. If one works, then they all work, provided you did your math right. Okay. All right, moving on. So we tested it and we found out that the region from negative infinity to 5 and the region from 8 to infinity. Notice, however, the graph, though, I have a bracket at 8 instead of a parenthesis. Why did I change it to a bracket on the graph? Yeah. Can I have a 0 in the top? Yeah. Yeah. X can be 8. Can it be 5? No, can't divide by 0. Okay. So the parentheses are for the test intervals. But when you get your final answer, then you have to ask yourself the question, can it include the endpoints? And if it can, you change it to a bracket. You never want to plug a key number in to see if it's going to be a true or false statement. Questions on this problem? And this next slide is going to talk about what I just talked about as far as the 8 changing to a bracket. Because negative x plus 8 divided by x minus 5 equals 0 and x equals 8, you can conclude that the solution set consists of all numbers on the intervals. So my solution is here. When I wrote down the separate areas, just like they did, oops, it was on, yeah, it was on that previous. 1 second. I'll get there in a minute. Notice they didn't put unions here for the test intervals. The test intervals was just some numbers, okay? And that's how I wrote it down as well. But when I write the solution, we do have a union because that is a solution to the inequality.
Wait, so then why is there a parenthesis on the side?
Because we can't divide by 0. If you plug a 5 in here, you get a 5 in the denominator, a 0 in the denominator. Other questions? Okay. And that's it for 1C, for 1.8C. There are 4 practice problems. I'm going to do the 4th one. Okay, because the 4th one's the hardest. Okay. It's the hardest, but like I've said before, everything in here is easy. Number 4, is that general form? No. How do I make it general form? No. How do I put it in general form?
You have to have it set to equal, or to 0.
Set to 0, right? Now, does it matter which way I go?
No.
Okay. I could move this guy over or this guy over. It doesn't really matter. In this case, I honestly don't see a benefit to one over the other. Okay. So I'm just going to go ahead to make 0 on the right side because that's what I'm used to. I'm going to subtract 1 over x minus 3 from both sides. So I have 2 over x plus 5 minus 1 over x minus 3. And again, I'm going to change this to an equation because I'm solving the related equation. Just because right now all I'm doing is looking for my key numbers. Can I combine those? I cannot because denominators aren't the same. So what's the common denominator? No, not negative 15.
Well, like, it's x minus 15.
Multiply what together? Multiply denominators together? Okay. Yes, but I'm not going to do that.
There would be exponent in the denominators.
Okay. That is correct, but I'm not going to do that because I want to know what makes the bottom 0. So that's where we're going with this. What is the common denominator? It's not going to have, well, it would have a negative 15 if I multiplied it out, but I'm not going to do that. This did not, well, how about this? What's the common denominator? Where'd that come from? 2 times 3, which is what you're trying to do, right? How do you turn this into a 3, to a 6?
Multiply by 3.
So I just multiply the bottom by 3 and call it good?
And multiply the top.
Okay. What do I do to this side?
Wait, would it be 3, 6?
Okay, right?
Oh, okay, so
Now I have a common denominator, which means you might say the common denominator is 6, but couldn't I also say the common denominator is 2 times 3? Does that make sense? Using that same logic, if the common denominator of this is 2 times 3,
5 times
isn't the common denominator of this x plus 5 times x minus 3? Which means to turn this into an x plus 5 times x minus 3, what does it need? And the bottom by x minus 3. So I'm going to multiply this one by x minus 3 over x minus 3 times 2 over x plus 5. And again, I think it's better to change it to an addition problem. So I'm going to make that 1 a negative 1. So this is going to be plus, what do I multiply that one by? Okay, x plus 5 over x plus 5 times negative 1 over x minus 3. Okay. Has anybody totally lost out what just happened? To get a denominator that's the same.
You're just like,
Can you think of another way?
so wait, you're just pulling it out,
No,
like pulling it
you were
apart, so
saying
it's
that
not,
we just multiply.
so we
them
actually have a
together.
denominator.
Do what?
You're saying that multiplying them together. Why did you choose to do it this way rather than just?
We don't have an exponent in the denominator.
What is x minus 3 divided by x minus 3? All I did was multiply this fraction by 1,
Which is the-
which gives me an x minus 3 x plus 5 denominator. What is x plus 5 over x plus 5? And if I multiply these together, that gives me an x minus 3 and x plus 5 denominator, which means once I multiply these, I do have the same denominator. The kicker is, guys, I'm not going to multiply them. I'm just going to keep them both.
So we have a denominator.
Okay. Now, what's this top part here, right here?
2x minus 6.
So I have 2x minus 6 over x minus 3 times x plus 5 plus negative x minus 5 over,
Plus 5 times x minus 6.
okay. Now, denominators are the same, correct? So I can combine the top. Combine the top, what do you get? Over x minus 3 times x plus 5.
So those two cancel each other out.
What's that?
The denominators wouldn't cancel each other out. You'd like
How would they cancel each other out?
x minus 3 and x plus 5, and x plus 5 times x minus 3, wouldn't that equal to 0?
Is 3 times 2 and 3 times 2 going to be 0? No, it's going to be 6. I said and. Is 3 times 2 and 3 times 2 going to be 0? I'll check the recording. I'll check the recording in a little bit. Okay. What are my key numbers?
3, 5, and 11.
Okay. So what are my regions? Let's go from negative infinity first, small to large. Three to 11. Okay, so I've taken that infinite number line and separated it into 4 pieces. Now what do I do? Test each one. Okay. So I've got 2 over x plus 5 is greater than 1 over x minus 3, And let's just try some numbers. A number between -8, I'm sorry, negative infinity and -5. -6. So let's see what we get there. That'd be 2 over -1 is greater than 1 over -9. -2 is greater than -1/9. True or false? False. I need a number between -5 and 3. Great choice. 0. That gives me 2 over 5 is greater than 1 over -3. I'm pretty sure a positive number is bigger than a negative number. This is true. I need a number between 3 and 11. Okay, I would have used 4, but I heard 10 first. That gives me 2 over 15 is greater than 1 over 7. Now, man, I don't know. I don't know my fractions that well to know which one's bigger, but I do know I can type those in the calculator and get a decimal equivalent. Okay, so 1/7 is bigger. Okay, so this would be a false statement. And a number between 11 and infinity. 12. I'm glad someone didn't say it's like 643 or something like that. 12.
I thought about it.
About 643. 2 over 17 is greater than 1 over 9. True or false? You type in your calculator.
217.
That's a true statement. Okay. Which means the answer comes from this one and this one. So my solution would be -5, 3 union 11, infinity. Any equal signs? Any brackets?
But there's no equal. It's not
Okay, so a bracket on the 11.
It's not greater than or equal to, right?
That's my numerator.
Oh.
Is there an equal sign up here?
So would it be right? You have to-
So can it be equal? Can it have a bracket? There's no equal sign? Okay. There's no equal sign. If there was an equal sign, if it was greater than or equal to, could it have been 11? Yes. And the next slide is going to be the answers to the practice problems. Y'all have all 4 of these practice problems, but I just did the hardest of the 3 of the 4. And there's the answers to all of them. And folks, that's it for 1.8C.